Let's talk a little bit about subsets, and we're going to look at the different symbols and then go over some examples just to clarify these concepts. Here we've got listed a set A and a set B. So if set A is the elements in set A are 2, 3, 4, and 5, and then the elements of set B are 2 and 3, then I could say that set B is a subset of set A because every element that's in set B is also in set A. I could not, however, say that A was a subset of B, so I would have to say that A is not a subset, so we'd use the subset symbol, and then as you cross through that, that becomes is not a subset of set B. Okay. And then the next example here, set A contains cassette, CD, and video. Set B, CD, video, and cassette. So we notice we have the same elements in both sets. And we would call those equal sets because they have exactly the same elements in each set. So we could actually say that A is a subset of B because every element in A is also in B. We could also say that B is a subset of A, and then with the definition of equality, we would say that set A is equal to set B. They would also be equivalent sets. Equivalent means that they would have the same number of items in each set. So just a couple more examples with that concept. Here I have set A and set B. We're looking at the definition of a proper subset this time. A is a proper subset of B if and only if all the elements of A are elements in set B, but the two sets can't be equal to each other. In this case, the two sets are equal. So I would say that set A is a subset of set B. Also, set B is a subset of set A. However, A is not a proper subset of B. And we could say the same thing about B, that B is not a proper subset of A. So we would say A is not a proper subset of B. B is not a proper subset of A. So let's go through these examples. We're going to mark them as either true or false using the above sets. Okay, so if you're asked, 3 is an element of A. Okay, 3 is indeed an element of the set A, so that would be true. But notice the symbolism here. Notice that here, because of the set brackets, this indicates that this is a set. So we're saying the set that contains 3 is an element of A. That would be false, because if it just said 3, 3 is an element. But to be the set that contains 3 being an element, that would actually have to be one of the listed elements of the set, like that. So we're going to have to say that this one is false. If just this symbol had changed and was a either proper subset or a subset symbol, then it would be true. But this is not an element of A. Is A a proper subset of B? Now the elements in A are not contained in set B, so that would be false. Is A a proper subset of set C? Every element in A is also in C, so that would be true. Is C a proper subset of A? Is every element that's in C also in A? And it's not, so we would say that that's false. Is A a proper subset of the universal set? 2 and 3 are also in the universal set, so that would be true. Is A a subset of A? So what we're asking is, are the numbers 2 and 3, is the set that contains 2 and 3, 2 and 3 are also in set A that contains 2 and 3. So it does actually follow the definition and is true. However, A is not a proper subset of A because they are the same set. So we would state that that's false. Okay. Now, the empty set, is that an element of A? That's not one of the elements listed. So the empty set is not an element of A. That would be false. However, the empty set is a subset of every set, including itself. So as we go through the rest of these, consider that. And let me say that again. The empty set is a subset of any and every set, including itself. So if I ask, is the empty set a subset of A? That would be true. It's a subset of any set. Is the empty set a proper subset of A? That's also true, because the empty set is not the same as the set that contains 2 and 3. So that would be the only other set that we would exclude and say would not be a proper subset. Is the empty set a proper subset of the empty set? Now, we could say in number 13, the empty set is a subset of itself. That's in the definition. However, because it's exactly the same set, we would have to say that it's not a proper subset. And is the empty set a subset of the universe? That would be true. It's actually a proper subset, and that's what the question asks, so that is true.